discuss the Leetcode 1022 problem. That is, sum of root two leaf binary numbers. Okay. So let's see what the problem says. You are given the root of a binary tree where each node has a value either 0 or 1. Okay. So node values which are present are either 0 or 1. Each root to leaf path represents a binary number starting with the most significant bit. Okay. So for example, if this is your binary tree, okay, here if we consider this path, for example, let's take 1, then 0, and then again 0. Okay. So this path numbers are 1, then we got 0, and then we got 0 again. So here the corresponding integer that will be formed will be 100. That is in binary, and when we will convert it in decimal, we will get the answer. Okay, we have to basically convert it into the decimal. Now, for all leaves in the tree, consider the number represented by path from root to that leaf and return the sum of these numbers. Okay, so what we have to do, for example, let's take a test case. Okay, so here is my tree: 1, 0, 0, 1, 1, 0. Okay, so I have done a slight modification. Basically, to explain an edge case, I have removed this node. Okay, so this is my binary tree. Okay, now let's traverse and see what are the sums which are coming. So here, let's start from the first node. Okay, so 1, then we can either go on the left hand side or on the right hand side, right? So let's go on the left hand side. We will get 0. Moving again on the left hand side, we will get 0, right? So what is the value in binary? It is 100 in binary, right? And how to convert it in the decimal form? Its decimal conversion will be like 2 raised to the power 0 into 0 plus 2 raised to power 1 into 0 plus 2 raised to power 2 into 1, right? So which is 4 plus 0 plus 0, that is 4, right? So this is the conversion. Now I wanted to teach you a method to do this conversion directly while iterating only. For example, the first integer which I encountered here, that is the root, is let's say 1. Okay, let's keep it in x. Okay, so x equals to 1. Then when I move to this node, what I will do, I will update x in this way. Okay, so let's just see the updation case. What I will do, x equal to x into 2 plus the root value or the node value which you got. So earlier your x was 1 when we were in the first node. When I move to this 0th node, right, in this child node, what I will do, I will update x. So my x will become earlier x, right? That is 1 into 2 plus root value, that is 0, right? So x has become equal to 2. Okay. Now, again, when I will move to the child node of this, that is this 0th node, again, my x will be updated. So my new x now will be the older x, that is 2 into 2 plus root value, that is again 0. So it has become now 4, right? So you're getting it, what I'm trying to do here. What I'm basically trying is I got my x initially, right? So here I got my x, which was 1. Then in the second move, what will happen? Basically, this 1 will be shifted on the left hand side. So it will be multiplied with 2. So x will be become like 2 into 1 plus the new value that is coming, which is actually 0. Then this x will again become 2 square, right? So this whole thing will be multiplied by 2 now. So it will become 2 square times 1 plus 2 raised to power 1 times 0 plus that new value which is coming, right? And as you can see, this is actually equivalent to what we do in our conversion, right? See here, it has become the same thing. This was when your first node was there. Then when the second node came, it became like this. And when the third node came, it became like this, right? So you got the approach of updation. like how we will update my integer while traversing. Okay, now how to traverse? So that's not at all a big deal. For traversal, I will simply use DFS. Okay, so I will use DFS traversal. Let's see what we can do. Yeah, this was your first node, 1 and 0. Okay, so let's try to write down the pseudocode on DFS. Okay, so yeah, so this DFS will return me an integer, which will be basically the sum in DFS. Here, one parameter will be your root, right? So we node are root, and another parameter will be your x, which I am taking. Fine. Okay. Now just see here. Let's say if I started from this node, okay, one. So what could be my base cases? That let's think of that. So my base cases. For example, while starting my traversal from one, I went to this, okay, and after this, I went to this node, which is actually a null, right? So if null is encountered, you have to return a zero because once you get into the null, there is no possibility of going into any other node because the left and right of null is nothing, right? Right? It's just a garbage value. So let's include it in the base case. So if root is equals to null, it means that you have to return zero. Okay. Otherwise, what you have to do, see, if you encountered a leaf node, how can you identify a leaf node? So the only identification of leaf node is, for example, this is a leaf node. So the only identification of leaf node is that its left is also null and its right is also null. Okay. So let's write down if the root left is equals to null, and then your root right is also equal to null. Okay, so if you have encountered the null, basically leaf node, what you have to do, you simply have to take the value of the leaf node, that is 0. Okay, so let's do that x updation, x equals to x into 2 plus root value. Just take the value and return this. That's it. Okay, so once you have encountered a leaf node, since the question asked you, you have to return the path ending at leaf node. So you will just return this x value. Okay, means this x corresponds to the sum of this path, that is 100. Okay, otherwise you have to just do a normal traversal. So here you will return DFS of, before traversal just update the x. Okay, so x will be equals to x into 2 plus root value. Okay, basically take the value of the root here corresponding to it and then return DFS root of left comma this new x plus DFS of root of right comma this new x. What I am doing here basically is, for example, let's try run for this. So yeah, okay, let me just remove it. Okay, so if I'll try run for this, what I am doing here, first I got into this one, right? So is one equals to, means is root equals to none? No. Is root left and root right equals to none? No. So what I will do, I will just go here. So I'll update my x. Okay. So x was initialized with 0. So x was initialized with 0. After that, when I reach this node, I will update my x. So my new x will become, that is 0 into 2 plus root value, that is 1. So my new x has become 1. And then after that, what I will do, I will basically add the values which are coming from the left, basically left of this node and right of this node. Okay. So 1 plus DFS of node from left plus DFS sum basically from the node. Okay. So again, let's move on to the left node. Left node is 0 again. So this x will be again updated. So how will it be updated? This new x, that is 1 plus 1 into 2 plus this value, that is 0. So it will now become, basically this DFS left is being calculated here, right? So yeah, it will become like 2. And then again, I'll move on the left x will again become, that is 2 into 2 plus the value, that is 4. Okay. And since the left and right both is null, so this x will only be returned. So this x will be returned here, and this 2 will go to this space of 1. Okay. So this VFX of left will come out to the 4, right? This 4 will be returned here, and this 4 will come here, right? So in this way, your basically this 4 will not be returned. Basically, your final x will be returned 4 directly from here. Okay, this DFS function will directly return here. Fine. So this is how you have to do this. Let's move on to the code so that it will get much more clear there. Okay, so yeah, let's write the DFS function, and DFS one parameter will be your root and another parameter will be your x. Okay, so if root equals to null, then in such a case return 0. Okay, otherwise let's update your x equals to x into 2 plus root value. Okay, now if we got a leaf node, basically I have updated this x earlier so that I don't need to update it inside this leaf node checking case also. Okay, so if root left is equals to null, and then root right is also equals to null, in such a case just return x. If the node is not leaf node, then return dfs root left comma x plus dfs traversal of root right comma x. That's it. Return dfs root comma 0. Okay, so we basically initialize the x with 0. Okay, let's submit it. Yeah, it got accepted. Okay, so thank you. I hope that you have got the solution. And if you have any doubt, you can write it in the comment section.